So in this video, what I'm going to do is go over solving a rational equation. Solve this rational equation. Again, we keep saying over and over again what rational means. Rational, ratio, fraction, right? Equation, an equation will be something with an equal sign. Solve means you're going to be getting an answer for your variable, whether that variable is x or that variable is another letter. It's all good. Solve this rational equation, put a little semicolon there. We're going to have an extension to this, and we're going to state restrictions. Now, restrictions play a role in the graph that goes with an equation as well. And this is going to be super important. So we chatted about that a little bit. We talked about removable and non-removable, and I'm really hoping we can get into that a bit today. That'll be fun. And the one we really want to do is this over here, 7x plus 1 over 2x plus 5. This was your one homework question. Plus 1 equals, and it's really spacing it out, 10x minus 3 over 3x. So what I'm going to do over here on the side is I'm going to do a question very similar to this exact question, except I'm just going to use some shapes, heart, smiley face, you know, whatever, little like Lucky Charms or something over here. And we are going to show what needs to happen and what needs to get done when you have this kind of a setup, okay? When we have this kind of a setup. So I'm just going to go right here. I'm just going to put a little separator. And let's say we had something like, I'm getting a little carried away, but all good. I have heart over, you may have to shout some different shapes at me because I might run out. So I'm going to do a heart over a smiley face. If you think of something that's easy to draw, please let me know. Heart over smiley face plus, what about a star, right? Equals, and now I still need two more things. So what about a flower? Right? Over, oh no, what else could I do? Flower over a, I guess, what about a sun? Okay, so here we go. You have an equation. It doesn't matter if the equation that you have, similar to this one, has bigger and beefier numerators and denominators. Okay, so here 7x plus 1 is what is being represented by the heart. 2x plus 5 over here is being represented by the smiley face. The 1 is being represented by the star. The 10x minus 3, that whole entire big chunky quantity, being represented by the flower. And then 3x, that whole entire little package, is being represented by the sun. So we have all these different things going on over here. Now, you have more than one way to do this. So one way to do it, more classic and traditional way, is to find a common denominator on all the pieces. To me, this is a lot more writing, a lot more work, but it's fine. You know, if that's what you like to do, you can do it that way. So option number one, I need all of them to have a smiley face on bottom if one of them does. So I'm going to go over here. I'm going to multiply this both on top and on bottom by smiley face, okay? You could just be watching this part. You don't need to copy this part. Here, I'm going to do the same thing. Multiply on top and on bottom by smiley face. Anytime we multiply on top and bottom, you're multiplying by 1. All good. Now, they almost all have a common denominator, but this bottom, this denominator has a sun in it as well. So I need to multiply this one over here on top and on bottom by the sun. Again, you're like multiplying by 1. Totally allowed to do this. And I'm going to do the same thing over here. I'm going to multiply the top and the bottom. Order doesn't matter. It's called the commutative property. It doesn't matter which way we do it. But top and bottom by the sun. Now, they all have a common denominator. They all have sun, smiley face on the denominator. Now, in the next step, in a way, what's happening? These already have a common denominator. So you have a fraction equals a fraction, because I'm going to take these two, we're going to bring them together right now. How do we bring them together? We have heart times sun. That's this numerator. Now, can we always multiply things? Not always. What if it was just x times y? Well, then you have xy. What if you have 2 times 7? You don't leave it as 2 times 7, you get 14. It depends on what you have, okay? Sometimes, when you do the multiplication, you get 2 new things, and sometimes they kind of stay separated. So if you are pouring M&Ms and Skittles into a bowl, you're pouring them in the bowl. Do they blend together? Not really. You could still separate them. So that would be something like X and Y. But if you poured iced tea and lemonade into a bowl, well, now they blend together. That's like the 2 times 7, you get 14. You kind of get something new, and that's the end of that. Okay. So, and anyone who got here late, there was a warm up on Classroom. Make sure you read the description, but it's going to close in 7 minutes. So you might want to take care of that and get that done. Now carrying on with that here, sun times star, case by case basis, we figure out, can I actually multiply them or, and get a new thing, or do they just go right next to each other and stay like that? We'll figure all that out. Now, if a problem was originally given to you kind of like this step right over here, where that part had a sun, that part had a sun, and the denominator has a sun, that would be a case where you can use the pretzel to reduce. But the problem is we don't want to do that, because we put those things there so we could have a common denominator in the whole problem. All right. So you don't want to go back. This is what you guys, a lot of you do. And it's so funny. It's like, okay, I'm going to find a common denominator, and you start. And then after you find the common denominator, you cross it out. So it's like, I'm going to put on my shoes for today. You put on your shoes and then you take them off. What was the point? Like, if you put them there, why did you put them there? Keep going with it. Okay. Now, if both sides of your equal sign have one thing, okay, this is important. One big fraction, one big fraction. In the step before, we did not have that. We had this plus this. That was not one big thing. We don't have two different, we don't have one thing together. Now we do. When you have one thing equals one thing, we look for opportunities to use something called the one-to-one property. And that means that where you could kind of ignore one piece of it. So the one piece we could kind of ignore is the bottom. They both have a smiley face and a sun on bottom. We could kind of be like, well, this fraction equals this fraction. The bottoms are the same. Let's just focus on the numerators, right? And we solve that. So the one-to-one property, we're going to ignore these denominators as we solve, and we just carry on with that step. Heart times sun plus sun times star equals flower times smiley face. When you're solving, what you need to repeat to yourself many, many times is get the equation equal to 0. That is a big step that people skip. Get the equation to 0 and then factor in some way, shape, or form. And then after you factor, zip, 0. Product, property. And that's how we finish strong. And then we go and make sure we find and compare our answers. Find, compare with the restrictions. Sometimes your restrictions have nothing to do with your answers, and that's pretty cool. So it's like, oh my gosh, I just ate this whole thing. Am I allergic to something in here? And you find out nothing in there you were allergic to. And you're like, whew, I'm good, you don't have to worry about it. But if you find out, I was allergic to that, or I am allergic to that, I shouldn't eat that, right? Then you want to go from there. So when solving, okay? What do you want to always remember? Any problem solving. 1, you probably want to get it equal to 0. At some point, how you start is going to vary. 2, you're probably going to have to factor it. The only time you don't need to factor is if you only have a variable, when all is said and done, a nice equation, a variable that is only to the first power. You don't have anything to the second, to the third, nothing. So if that's the case, well, maybe you don't need to factor. Then 3, after you factor, zip, ZPP, 0, product, property. So we take each piece, each factor of the product, this times this times this, and we set it equal to 0. And then last, we're going to find our restrictions and we're going to compare the answers we got to our restrictions. You could do the restriction step first. You're still going to have to compare at the end after you get your answers. So let's apply what we just talked about here to the example I asked everyone to do for homework. Okay. So I'm going to try to go a little bit quickly. If you still have questions on it, please come and see me either after school or maybe at the end of class, after class, if we have a little bit of time, somewhere along the way. Okay. So try to color code. Let's see what we got. So here, 7x plus 1 is my numerator. Nothing to reduce, nothing to see here, no funny business. It's over 2x plus 5. That is my denominator, and we got to pay attention to that when we're finding least common denominators. Plus, we have a 1. It could be a 1, it could be a 7, it could be a 2x plus 5. It could be lots of different things. You want to think about this invisible denominator, so don't forget about that. Equals a 10x minus 3 over 3x. So here I had a binomial for a denominator. Here I have a monomial for a denominator. All good. I want to kind of take an approach like this. This was approach number 1. My common denominator was sun, smiley face, and that's what I ended up having. Looking here, instead of me having sun, smiley face as my common denominator, I have algebraic expressions. I have 2x plus 5 over here. What's this denominator on that part right there? What's the invisible denominator? Is it a 0?
1.
Good. It's a 1. Good. That's a 1. And when it's a 1, we don't have much to worry about right there. Kind of ignore that. You know, it just sort of hangs out. What would my least common denominator be? LCD, least common denominator. It's not going to be sun, smiley face, but instead it will be what? What is my least common denominator for this homework example? What would it be?
3x plus 5.
3x plus 5? I see where you're going with this, but the 2x and the 3x, you can't kind of blend part of a plus or a minus, like this little sum or difference over here, blend it with a monomial. That's like if you were like, oh, I have a denominator of 2, I have a denominator of 3. Would your least common denominator be 3? If you had a 2 and a 3 for denominators, would you make your common denominator 3 or something else? One over 2 plus 1 equals, well, let's just make it a minus so it's not equal to that. 2 over 3, blah, blah, blah. We said this is over a 1. What would I make my least common denominator if I were adding and subtracting fractions like this?
1.
Not 1. You guys got to get out of that habit of calling your least common denominator the smallest number. I say this every class. Your least common denominator, remember, is going to get to be a bigger number. Count by 1s, count by 2s, count by 3s. 6. Your least common denominator would be a 6 because you would need to multiply this on top and bottom by 3, then this on top and bottom by 2, and then this by both a 2 and a 3. What do they all have on bottom now? A 6. So you don't just blend them, you don't add them. Our least common denominator has to do with multiplication. So please really take this in, guys, because we've been spending quite a few days on this and you guys are still doing these same bad habits. Okay, the least common denominator is not 1. It is not a 2. It is not a 3. It is 6. Product, okay? Multiplication. So here and here, you multiply them. So my least common denominator, look again here. My least common denominator on my shapes is smiley face, sun. It's the product. It's not a happy sun. You don't do a sun with a happy face on it. It's the multiplication, the product of those things, okay? So this and this are what I have on bottom, and we just use multiplication to match them all up. We can't make things smaller, but we can just simply multiply things and make things bigger. So 2x plus 5 times 3x, or 3x times 2x plus 5, that is how we get the least common denominator, okay? Next, I will do this problem like this one, okay? I'm going to multiply this on top and bottom by what it's missing. What do I multiply this on top and bottom by?
3x.
Nice. 3x. So those of you who came for office hour, I showed you this using the method, my method where I clear it all out. So you get to see it both ways. And I think that's important. So this has both on bottom. What about this? What should I multiply this on top and bottom by?
2x plus 5.
2x plus 5. Good. 2x plus 5. Okay, nice. This has neither of those things. Neither, whatever. This has nothing. It has just a 1. Plain Jane over there. So this is going to get the 3x on top and bottom. And it's also going to get the 2x plus 5 on top and bottom. It gets both. All right. So instead of highlighting it, I'm going to circle it in that color so we know which ones were there originally and which ones we added to the problem. And I should not use the word add because we're multiplying, but you know what I mean. Like I threw into the problem. And then here is that 2x plus 5. So they're same color, but I'm circling them so we know that they are not originals and we added them or supplemented the problem with them. Next step, common denominator. Guess what they all have? They all have purple times blue in the denominator. So on the right, that was cool because we already had just one expression, no plus or minus separating it from another expression. So all I'm going to do is I'm going to rewrite this step. Now you might have done it slightly differently. That doesn't mean you're wrong. Because if you use the other method that, I've shown you my technique, then that's okay. It's going to look slightly different. Here, I'm just going to put the 3x in front of the 7x plus 1. So I'm going to write it like this. 3x times 7x plus 1. And then here's the plus sign. So plus, I don't need to write the 1, but I have 3x times 2x plus 5 all over 3x times 2x plus 5. Do I need parentheses around 3x? No. Can I put them? Sure. Do I have to? No. All good. Now, that's what we have in this step. They have the same denominator. That's this step. If both sides are just one thing equals one thing. Now you could do this if they have the same denominator, when they have the same base. So if you have a number to a power equals a number to a power, and that number, the base, is equal, we could set the powers equal to each other. So what can I do with this 3x times 2x plus 5 that's on bottom of the left and the right side? What can I do in this step? What can we do in this step? We can... Nothing? Come on, guys. 8:36 in the morning. Wake up.
Keep, change, flip.
No. When did I say keep, change, flip today? Not a once. Not a once.
Sorry.
Look what we did over here, honey bunnies. We had one
fraction.
Not yet. What did I do? Look, guys, don't just pick math phrases and yell them at me. I had a fraction equal to a fraction. I made it one thing equals one thing. What did I do in the next step?
You cancel the denominator.
I ignored the denominator.
You just missed
Yeah, Paige used the word dismiss the other day. We're ignoring it. That's what I keep calling the one
But
to.
isn't it the same thing if you combine the like terms and just forget about it?
But how do you forget about it when you what are you combining? What am I going to combine over here?
The numerators and just leave the
Well,
denominator.
that'll be
just
eventually I'm going
write
to
it.
expand on the numerator, but why would then somebody, maybe they would expand on the denominator. Maybe they would make that 6x squared plus 15x, you know? And here's a big rule. D, D, D. Don't distribute denominators. Don't distribute your denominators. Leave your denominators factored, okay? Leave your denominators factored. So what we're doing is we're ignoring the denominators because they match. It's called the one-to-one. Now I'm going to expand, that went a little too far, expand my numerator. I'm going to open everything up. I'm going to expand my numerator. This, I don't just simply distribute like here. Here I have to use our favorite four-letter F word, FOIL. What do I get on the left side when I expand? What do I get over here? What do we get? 21x squared. Good. Wow, guys. Great participation. Next. What do I get next?
I like
Plus 3x. And what was your concern question?
I rearranged it so that the like terms could like add easier.
What like terms yet? I just don't have any yet.
Okay, so it's 21x plus 3x.
21x squared.
Right, sorry. Plus 6x.
Plus 6x squared.
To the second.
Good.
Plus 15x.
Good, thank you. That's this side. So everything that has an x to the second, I'm going to underline it 2 times. Everything that's just an x, I'm going to underline it 1 time. So I know what my like terms are, like you said. And then here on the right, we're going to FOIL. Can anyone help me FOIL this? 20x squared plus 50x minus 6x, last times last, squeeze it, minus 15. Right at the end. All right, and that didn't get underlined. 21x squared plus 6x squared is 27x squared. 3x and 15x, they're both positive, and we get 18x equals 20x squared. No one to combine yet. 50 take away 6 is 44x minus 15. Now, what did we just say? When solving, get equal to 0. Let's get this bad boy equal to 0. Let's take all this stuff on the right and let's scooch it over and get it on the left. So we're going to subtract 20x squared from both sides. 20x squared, 20x squared. If it doesn't have a like term, please, guys, stop making up your own rules and combining it with something that it's not like. Only combine it with things that it's like. Otherwise, you just put it next to that thing. All good, all good, all good. Minus 44x minus 44x. All right, that, adios, that, adios. Add 15. And I got nobody to combine it with, so I'm just going to stick plus 15 over here. What do we get? 27 take away 20 is 7x squared. Positive 18 minus 44 is the same as 44 minus 18. Change the sign. 44 take away 18 is, ooh, I'm shaking the desk, sorry, is what? 44 minus 20 is 24. Add back 2 more, 26. Make it negative. 26x plus 15 equals 0. Good. Then we got to factor this. Guess what? I'm not going to show you the factoring over here. If you need help with factoring, please come to office hour. Here, this will factor to 7x and x. We will have, I believe, this. Correct me if I'm wrong. Anyone who did
You're
the,
right.
I'm good, thank you. Then after you factor, so we said get it equal to 0, factor, and then 0 product property. That means you set 7x minus 5 equal to 0 and solve for x. I'm going to add 5 to both sides. 7x is 5. I'm going to divide by 7. X equals 5 over 7. That's one answer. Then the other one, I'm going to set x minus 3 equal to 0. Add 3. I'm going to get x equals 3. That's another answer. We got our answers, but find and compare it with your restrictions. How do I get restrictions? You go back to the original problem and you look at all your denominators. My denominators were 2x plus 5 and 3x. And we set our denominators. What do we do with our denominators? We set them blank to 0, not equal to 0. We set them not equal to 0 because they're not allowed to equal 0 because you're not allowed to have a 0 in your denominator because a denominator is what you divide by. And we cannot divide by 0. Dividing by 0 gives you an answer that is good, guys, undefined. So x is not allowed to equal negative 5 over 2. Oh man, did I get negative 5 over 2? Nope. So this restriction, no problemo. Not worried about you right now. What about the other part? 3x. We set it not equal to 0. I got to get x alone. Do I get that x cannot equal 3 or negative 3 for this step? What do we get?
No, you get x equals 0.
Cannot
X
equal
cannot
0.
equal 0.
Because you divide by 3, and 0 divided by 3 is 0. If you had that, x minus 3, that's when you would get 3. If you had x plus 3, you would get negative 3. So that's our other restrictions. So what are our restrictions? We can't equal these two numbers. Do they play a role in our answers? Do they interfere at all? Nope. We're good. If you got this correct, whether you did it this way or another way, bravo, high five yourself. Give a thumbs up on the video if you're watching the video. If you got it wrong, put a thumbs down, and I will see you in extra help.